When we introduced the primitive types, remember the chart where we had divided them into categories for integers, real representation, and then booleans. We also mentioned the char type, and this is the type through which we represent characters that make up a string. Now, you may recall an oddity when we were talking about the primitive types chart, and that is the fact that we placed the char type among those types through which we represent integers. It was together with short, byte, int, and so forth. Isn't that an oddity? Not quite. And to this, it will help us to remember the fact that a computer cannot understand symbols. It cannot understand letters. The only thing that the computer as an electronic machine can understand is numbers, binary numbers, or the representation of states, two states, low voltage, high voltage. So we need to take advantage of this fact in order to be able to represent symbols. In other words, we will be mapping characters to numbers. This is exactly how we are representing symbols. For instance, when we press A on the keyboard, then that symbol is actually represented in the machine as the number 65. The letter B is represented as the number 66, and so forth. So this is why we placed char under the integers, because it really is an integer. And you may recall from that chart that we said that the char type uses 2 bytes, and we are using unsigned representation. In Java, a character has 2 bytes. Whenever you are coming across characters in programming languages, you will almost always also come across what is called the Ascii table. This is nothing other than a mapping from numbers to symbols. It is a table which shows which numeric value represents which particular symbol. The Ascii table represents 127 characters, and then it was extended to the Latin 1 character set, which is able to represent 256 characters. What Java uses is the Unicode character set, which can represent many more characters. Now notice that the numbers that we are mentioning here are not random, and if you have learned the powers of 2 up to the 10th, as I had recommended in a previous topic, you may have already recognized that. 128 is 2 to the power of 7, which means that we can represent with 7 bits all the characters represented in the Ascii table. So the Latin 1 extension just took advantage of 1 more bit, because 256 is 2 to the power of 8. And with 1 byte, we can then represent all of the characters in the Latin 1 character set. Now, the Unicode set uses 2 bytes, so the number that you see on the screen for the Unicode character set is nothing other than 2 to the power of 16. You may be wondering, why do we need these extensions, and what kind of values can we actually represent with these sets? With the Ascii subset, we have the values from 0 to 127, and these include pretty much the English alphabet, the numbers, the punctuation, and some special characters. We would say the bare bones of what is needed. The Latin 1 extension added 128 to 255, and it included some non-English characters and some more punctuation. And finally, with the Unicode set, that we have a much larger set now, we are able to represent characters from the Cyrillic alphabet, from Hebrew, Arabic, Chinese, and so forth. You will also hear the expression char literal. What is a char literal? It is any single character, and the way that we represent single characters is through single quotes. Remember, every time we put double quotes around a string, that is representing a string. Whenever we are putting single quotes around a letter or a symbol, that is representing a character. Now, these kind of characters you might have expected to be char literals. However, even some special characters, which we call escape sequences, are also literals. And again, they are represented by single quotes, even though it seems like we're putting two characters inside the single quotes. The \t represents tab, for example, \n represents new line, and so forth. Especially, you should probably take a look at the very last line in the slide. \u and then a hexadecimal number represents the hexadecimal character in the Unicode set.